So as I told you, my topic will be on cyber security in power system, and this is the topic which many people have not touched, and many people doesn't know the importance of this topic, and it will become a threat in a few days because many of them are talking on smart grid and the importance of smart grid, etc. Whenever you have connected your system to the internet, you are prone to attacks. So you will get attacked easily. For example, if you are connecting your machine with the help of internet, that machine may be erroneously switched on or switched off without your knowledge, and it may be unwantedly switched on by a hacker. So this is a very great problem in smart grid, and this has to be addressed. And the addressing of this in the sense, first thing you need to know what are the types of attacks in a power system, and secondly, how to identify that attacks, and then you need to provide a solution. So in this presentation, I'll be touching upon three important points. One is what is cybersecurity, and why an electrical engineer should know about cybersecurity. And as an electrical engineer, we are talking more on many aspects like generation, transmission, distribution, and utilization. In all these sectors, right from generation to utilization, we have the chance of attack by these hackers. So we need to give a proper solution, and we don't have a proper protocol, and we don't have a proper standard. Even we have certain standards and protocols, but before connecting a machine to the internet, we need to follow certain protocols. For example, you take a mobile phone. Many of you have a mobile phone. So you are unknowingly downloading many applications because of interest or because of people are forced to do, etc. So this software may take your personal data, and this data will be used by many people without your knowledge. You may say that I don't have any data. For example, your name itself is a data. Your mobile number itself is a data. Your email ID itself is a data. What people can do with that data, they can do wonders. Okay, so you need to know about this. Many of the words what I'm going to tell to you now may be afraiding you, but this is the fact. Being an engineer, you need to understand the importance of your data. So this is your personal data. Similarly, the power system consists of so many data, and these data are available to everyone when you are connected in the net. How you are going to connect it to the net, we will see that. So how do I secure this? How do I secure my power system? Let us say I give a common example. Let us say one near to your house, your one building is getting constructed. You have a vacant land, and your building is being constructed in that vacant land. So people can take your power and they can use your power for constructing the entire house. This is a theft. This theft we call it as an electrical theft. Technically we call it as a pilferaging. You need to understand the terminology pilferaging. You just Google it and check. There are different types of pilferaging. One of the pilferaging is cyber security. Like stealing your power with the help of internet. Just give an example. Stealing your power with the help of internet is one of the type of pilferage. This is only for domestic application. This can happen everywhere. Okay. Now we know the importance of power, right? We know the per unit cost. You know what is happening in Sri Lanka. You know what is happening in India. You know what is happening in India for the fuel prices. So all these matters. So you need to understand the importance of cyber security in power system. I'm just trying to explain to you people why cyber security, the topic is important for an electrical engineer. Okay, let us go on to the presentation now. So a famous director, Robert S. Mueller, he has said a famous quote. One second. Uh, the quote goes like this: there are only two type of companies, those that have been hacked and those that will be hacked. So this is the statement given by him. Organizer, am I audible, and do you have any questions in the chat box?
No, sir. You are audible, sir.
Okay, fine. And meanwhile, if you have any questions, please allow the people to ask even in between the presentation.
Okay, sir. Okay, sir.
So there are two type of company: the company that have been hacked and that will be hacked in the future. But that code has to be re-quoted like this: there are only two type of company, those that have been hacked and those that don't know how they have been hacked. Means like every company will be
ஒரு
hacked.
11 o'clock வாக்கில்
Only
ஒரு லாங்
difference is the
ஸ்க்ரீன்ஷாட் எடு.
company may know that they have been hacked, and the another company they don't have the awareness of hacking, etc. So once the companies are connected to the net, how the company can be connected to the net, even through mail or even through WhatsApp, all are communicated through this mail and WhatsApp, then that will be prone to hacking.
மயூரி நம்பர் வச்சிருக்காரு.
So we are talking about smart grid. We are not talking about conventional electrical grid. We are talking about the concept of a smart grid. And smart grid has become a hype. Everywhere you go, people will talk about smart grid. It is the necessity now. And in this smart grid, we have a lot of communications. For example, we can call it as a power system communications. So we know one third of the Indian villages are not electrified, and all the grids in India are connected together, are interconnected, and our power supply demand is getting increasing. And we need to have a proper security, and we need to have a connected network. So once these grids are connected, why these grids are to be connected? Because let us say Tamil Nadu generation is more, and let us say Karnataka generations are less. The Tamil Nadu generation can be supplied to Karnataka. India is getting supplied electricity from Nepal. I think many of you know about it. Example I am saying, India is getting electricity from Nepal. Tamil Nadu is getting electricity from central government. So all these grids are connected. So if all these grids are connected, then there are high chances for digital threats. By means of this power system capability, we need to control this generation, transmission, and distribution by means of SCADA. SCADA means supervisory control and data acquisition system. So, and these SCADA are required for communication and for controlling the substation. And these devices inside the substations are interconnected together. So, communication in the sense, for example, I think many of you people are electrical engineers. Let us say input is coming from the mains to the motor. In between the supply to the motor, there are a lot of switchgear components. For example, we have fuse, relay, contactor, starter. Example I'm saying. So all these devices are connected by means of wire. Let us say all these devices are connected without wires, wireless devices. So these things can be connected with the help of any of the communication media, wireless communication media, and these things can be controlled by means of SCADA. SCADA means sitting at a common place, I can able to control the entire operation of the system, entire operation of the power system, generation, transmission, distribution, etc. So for that, I need a SCADA. So everyone have mobile phone, right? So your mobile phone communication, let us say you have different vendors. Let us say you have Vodafone, Airtel, BSNL, etc. All are different vendors, and each and everyone have taken different subscription, and these are communicated through a communication protocol, and mobile is being communicated with the help of GSM, Global System for Mobile Communication Protocol. This is a protocol. let us say I have a protocol to talk to you. The protocol is nothing but English language. It's a protocol. And I am sitting at Coimbatore, you are sitting at various places in Tamil Nadu or abroad or in India. And we are getting communicated with the help of internet protocol. So this is called as a protocol. So each and every devices can be connected together with the help of a particular protocol. What do you mean by protocol? Protocol is a set of rules and languages for communication. This is called as a protocol. So, if I'm communicating to a device with the help of a wire, it is nothing but a wired protocol. If I'm communicating with the help of a wireless, it is a wireless protocol. And that wireless protocol can have different format. Example, it can be FM, frequency modulation, RFID, Bluetooth, GSM, NFC, IEEE 802.4. There are different communication protocols available. With the help of all this communication protocol, we can connect the devices together. So this is what happens in the case of SCADA. SCADA means supervisory control and data acquisition system. Let us say I have 60 students are there here. If I want to control all these 60 students, I need to communicate to the 60 students. If I have one device and if one device has to control all the 60 devices, these 60 devices have to be communicated with the help of a communication protocol, right? So if all these devices are communicated, then it can be easily possible for us to control. So in any of the system, these devices can be connected by means of different methods. It can be connected by means of computers, it can be connected with the help of operating system, it can be connected to in a network. For example, you being sitting at Kongunadu College, inside the Kongunadu College, you can get network with the help of local area network, LAN. If you want to communicate to PhD, then you need to connect it to the internet. So we have two things, intranet and internet. Intranet, if you are connecting within within your place. Internet, if you are connecting outside the places. So for different communication, we need to use different protocol. Similarly, if you are inside a particular system, you can connect it to a particular device with the help of a communication protocol. So once the devices are connected with the help of wireless protocol, then there is high chances for attacking by the hackers. That is what I'm trying to tell you people. So what is the organizational structure of a cyber security in a power system? As I told you, we are being connected with the help of a smart grid. No way we are connected to a grid simply. The conventional grids are crossed. We are connected to a smart grid. Okay. The smart grid will have the capability of grid integration. What do you mean by grid integration? I have generation, transmission, distribution, and utilization. So in each and every hierarchy, there are a lot of devices involved, and these devices have to be controlled, monitored, and operated. So that can be done remotely. Okay. So if I want to convert my grid to a smart grid, then that particular grid should have satisfied 7 properties. Those properties are, the requirements include attack resistance, self-healing. Let me take a pointer. Yeah. Attack resistance, self-healing, consumer motivation, power quality, generation and storage accommodation, market availability, and asset optimization. So all these points are involved for converting a grid to a smart grid. So in each and every point, we have a lot of components involved, connected to a communication protocol, connected to an internet, connected to a particular device. Okay. This is the conventional grid. Markets and operation, generation. Markets and operation will tell you the demand. Based on the demand, the generation will take place. The generated power will be transmitted by a transmission system, and depending upon the customers can be individual house, industries, or commercials. So depending upon the customer, it will get distributed. So this is called as utilization. So here this is a one way. Let us say in this home, let us say they have a solar. Let us say they have a rooftop solar. What if the generated solar PV from the home is returned back to this distribution? Is it possible? No, in the case of the conventional grid, because it is a one-day flow of electricity in the conventional grid. So the market and operation will tell the demand. Based on the demand, the generating station will generate electricity, and that will be distributed by a transmission system, and the distribution will take place via distribution, and it can get distributed to different utilities or different customers. But in the case of a power grid cyber physical infrastructure, we will be having a generation network, transmission network, distribution network, and we have domestic load, industrial load, and we have again separate distributed generation. And the distributed generation can be PV or wind or any type of generating station. And all these generating stations, distribution, transmission can be connected together with the help of WAN. WAN means wide area network. So inside the generating station, we can have LAN. Okay. If it is being communicated to other generating station, that is, I have one more generating station here, one more generating station here, and these things can be communicated with the help of WAN. Okay. So hope you people can understand. And let us say I have an energy market. Please go and see the POSACO website, POSCO, POSACO website. It will tell you clearly what is the current price of the per unit cost of energy. The per unit cost of energy which is being generated from coal, petrol, gas, solar PV, wind, waves, right? So what is the total cost? What is the individual cost of per unit which is being generated from different generating stations? That can be acquired by this energy market. So based on the need, the energy market pricing may vary. Depending upon the fuel, the barrel price, the price of 1 liter petrol, 1 liter diesel, everything will vary, right? The same thing happens in the electricity market also. So what will the smart grid look like? The smart grid, NIST, National Institute for Standards and Technology, they have given a proper definition for smart grid. So the smart grid involves generation, transmission, distribution, and customers. Apart from that, they have markets, operations, and service provided. And more importantly, all these are all connected together. So in a smart grid, you can have any kind of generation. Let us say I have in Coimbatore area, we have high wind. Similarly, solar PV generation is also possible. So high use of variable renewables can be integrated in the bulk generation. And even in my home, I can have solar PV system or any other generating station. Or in let us say I have a farm. In the farm, I can place solar PV generating station. Let us say it can be 2 kilowatt, 5 kilowatt, 1 megawatt, etc. And that generating station, we call it as a DG or distributed generation, or otherwise it can be called as a microgrid. That is possible. And I can connect smart meters. The purpose of smart meter is in my home, I have a 1 kilowatt solar PV system. And my monthly electricity bill, what I'm paying is zero rupees. Last 2 months back, I have paid rupees 30. This is my electricity bill. Okay. I have the AC, refrigerator, washing machine, everything, water heater, everything. But I'm facing zero electricity bill to tax. How it happens? I have, as I told you, I have 1 kilowatt of solar PV system. And this 1 kilowatt of solar PV system, I have connected to the grid. Okay, I have connected to the grid, and I have a small meter. And that meter, I call it as a bi-directional meter. If you have any doubt, you can stop me and ask me. That is a bi-directional meter. And what does this meter does? Here, whenever I consume energy from the grid, it will have a up counter. It will count the number of units which is being given to the home. Whenever I export energy to the grid, I have another meter. So simply it has import meter and export meter. And the total meter value is zero, then I no need to pay any amount to Tangentco. If the import meter is high, Tangentco will pay to me. If the export meter is high, if the export meter is high, Tangentco will pay to me. If import meter is high, I will pay to Tangentco. So this is called as a smart meter. This is a bidirectional meter. So my home is a grid now. That grid we can call it as a microgrid. So this is possible in the smart grid. I hope people will understand. If you have any doubt, you can ask me now. Any doubts? Any doubts to you? Any doubts? Okay.
Sir, no, sir. You can continue, sir.
This is called as a bidirectional meter, and I can have also a storage system. If I'm not connected to the grid, what I can do is like generated energy can be stored in a battery that is called as a distributed storage. And the pricing also I will understand, and based on the pricing, I can connect it to the grid. That is possible. And I can connect all the devices with the help of smart appliances. I can control my electricity bill. Meaning is, I can set my meter value to 100 units or 20 units. If it crosses 20 units, the meter will automatically switch off the unnecessary loads. That is possible. And energy management system is something like the service provider can able to have a control of all this generation, transmission, distribution, and utilization. So depending upon the customer's requirement, they may able to generate, and that is being controlled by means of energy management system. So similarly, in future, by 2030, people are saying that all the vehicles will be replaced by electric vehicle. So what happens if all the vehicles are getting charged at the same place at the same time? It may overload the particular distribution transformer. So it may affect the overall performance of the system. So that can be controlled or monitored with the help of this energy management system. And ubiquitous network sensors, meaning is, as of now, the present situation is, I don't know why the power cut has happened on a particular day. But if any power cut happens in future, it is possible for the customer to know with the help of the sensors integrated and sensors placed in the generation and transmission system. So if I have a small video, let me take. Is the video visible?
Yes, sir.
Yeah, this video will tell you the importance of smart grid and how smart grid will help you in future. Okay, please go to the video.
Primary power grids consist of a complex fabric of generation plants, substations, transformers, and transmission lines that supply electricity to cities, businesses, and industry. In addition to primary power grids, there exist smaller independent power grids called microgrids or remote grids. Microgrids provide power to islands, rural areas, and remote operations that have limited or no access to primary grid power. Traditionally, microgrids use diesel generators and diesel backup systems for electricity. In some microgrids, integration of renewable energy such as wind and solar arrays are used in combination with diesel generators. However, because they are limited in capacity to generate energy, microgrids are susceptible to potential inefficiencies that include high fuel consumption and reliability issues. Microgrids must continually manage fluctuations in demand and generation to maintain a 60 Hz frequency, which is a requirement for maintaining grid stability. Interruptions in this frequency can lead to power quality issues that can result in brownouts and in some cases, even blackouts. To regulate frequency, it is estimated that 10% of total generation capacity must be reserved for managing fluctuations in demand and generation. This reserved capacity is used to ramp power up or down to increase or decrease electricity to the grid, while the other 90% is dedicated to baseload power. However, Ramping isn't the most efficient use of generators. It consumes more fuel and increases transportation costs. It creates wear and tear on the equipment, increases maintenance costs, and leads to higher carbon emissions. Microgrids are also susceptible to the intermittent nature of wind and solar power generation. Variations in wind or partly cloudy days may cause significant minute-to-minute fluctuations in output. In response, diesel generators must ramp even harder and more frequently to smooth variations in renewable generated power, further increasing costs associated with ramping. Alternano offers a rechargeable, quick response energy storage system.
Okay, so I hope people understood the concept of smart grid. Smart grid will help the grid to maintain proper voltage and it can able to give a quality power. So that is the importance of smart grid, and people won't suffer from a power cut, blackout, brownout, etc. I think you know the importance of blackout and brownout. Blackout is a complete power cut. Brownout is something like what we face now is a brownout. Meaning is we won't give a quality output voltage. We need to get to that voltage constant, but it will not be.
போறதுன்னா போ
During the peak time,
நீ
the voltage
போறதுன்னா
may
போ
be
எனக்கு
dipped to
ஸ்கிரீன்ஷாட்
160
மட்டும் அப்பப்போ
voltage
எடுத்து
even.
அனுப்பிச்சுடு
During the non-peak time, the voltage may rise up to 260 voltage. So all the domestic appliances, if you see, the working range will be 160 voltage to 270 voltage. Meaning is even if it is 160 voltage, your appliances should able to work. So, but in the case of smart grid, it is possible for the generating station to maintain a constant 230 voltage supply always. So the smart grid, if you see the difference, this is a conventional electrical infrastructure. We have a market and demand can be decided and it can be given to the generation, then transmitted, distributed and utilized. But in the case of an intelligence infrastructure, this is an electrical infrastructure, intelligence infrastructure, or otherwise we can call it as a smart grid. In short, we can call it as an energy internet. Why it is so? Because all the devices are connected together. If one or more devices connected together through a proper communication protocol, then we can call it as an internet. In the case of electrical engineering, this can be called as an energy internet or it can be called as a smart grid. So if internet comes into the picture, then obviously cyber security problem will be occurred. Okay, that we will see. So current grid environment, as I told you, we are controlling the entire operation and control of a power system, generation, transmission, and distribution with the help of SCADA. And it has a limited cyber security controls. And it is used only in a specific area, only within the generating station, within the transmission, within the distribution. And all these are not connected together. And everywhere we are using only meters to measure the parameter. We don't use sensors for predicting the fault, for analyzing the fault, for detecting the faults, etc. And attackers can able to easily penetrate into a network with the help of any of the softwares. And I will tell you what are means for penetrating into it. And even unintentional occurs will result in destabilization of the grid in the case of a current grid environment. But now, with the introduction of smart grid, in the introduction of secure communication protocol, it is not possible for hacking. It is not possible for the attacker to attack the grid environment. And these are all the threats to the grid. Deliberate attack. For example, disgruntled employees. Disgruntled means dissatisfied employee. For example, an employee, if they are not satisfied with the industry, they may themselves hack or they may themselves spoil a particular equipment. And industrial espionage. Espionage means there are industrial waste which is available and that can be able to spoil the attack or spoil the script. Unfriendly states, organized crime. So these are all the deliberate attacks. And inadvertent threats are equipment failure. Because of the age of the equipment may fail. And because of the error in the user, the equipment may fail. And natural phenomena, for example, we can have a storm, hurricane, earthquake, and this may spoil the grid. And solar activity. If my grid is connected to the solar PV system, then obviously this output from the solar PV is not constant, it varies. and this may affect the grid. These are all the threats to the grid. And the new risks are greater complexity increases the exposure to potential attackers and unintentional errors. So the new risk something like when all the grids are connected, when all the equipments are connected. Let us say your mobile is connected to your home appliances. By mistake, it may be possible for you to switch on the TV. Let us say you have a refrigerator, TV, air conditioner, and a gas stove. All are connected to your mobile phone. You have an app. I think many of you know about that app, right? So, if, assuming all these four devices, what I have said, are connected to your mobile phone, and without your knowledge, instead of calling a person, assuming that you have switched on an AC, it is an unintentional attack, right? Unknowingly, you have switched on a particular device. The same thing can happen in the power system also. So power grid cyber physical infrastructure, as I told you, cyber system consists of many devices, many components. It consists of electronic field devices, communication network, substation automation systems and control centers are embedded throughout the physical grid for generation, transmission and distribution. And the purpose of the control center is for monitoring different parameters. What are the parameters I need to monitor? I need to monitor the voltage, I need to monitor the current, I need to monitor the power factor, I need to monitor the voltage regulation, I need to monitor the efficiency, losses, etc. There are so many parameters are to be monitored. And after monitoring, what should I do? I need to control it. And after controlling, what should I do? I need to do a decision making out of the output. So ISOs means independent system operators perform coordination between power utilities and dispatch commands to their control centers. And utilities, what they will do? They will respond to the command. So this is the entire cyber physical infrastructure. So I need you people to understand this particular slide. There is a blackout in US in the year 2003. It was happened in US Northeast region, and the cause is a software defect in a control room. A simple problem, a virus in a software which is being used for the distribution system, and because of that, the entire Northeast eastern region of US was in a complete blackout. You please Google it and see. The entire US was blacked out in the year 2003. This is, we call it a July 14 blackout. Okay. Restoration, some customers after 6 hours, some after 2 days, some remote places after nearly a week they have taken for restoration. And the consequences of this blackout is 45 million people in 8 US states, 10 million people in Canada. Healthcare facilities experienced $100 million lost revenue. 6 hospitals went on bankrupt for 1 year. You will understand the importance of this blackout now. Just because of this particular blackout, the US country has faced a huge loss. And after that, people understood the importance of cyber attack. Okay, even now cyber attacks are happening. Even now, Ukraine, I will give you some examples. Okay, in Ukraine, in Power Grid Corporation, they have faced an attack, and efficiently they have avoided that attack. How? They understood the attack will happen in future, and they have secured their environment. So this particular instance made the people to understand the importance of cyber security, and they have taken actions against these attacks. So what is cyber security basically? Cyber security refers to the protection of the network. Not only the network, it can protect the hardware and software from attacks, damage or unauthorized access and rejection of services. At this point, I would like to tell one example. I think many of you play the banned game PUBG. Right? Many of you know about this game. There was a sad incident happened 1 week back. I forgot the name of the place. One of the students, he suicided himself because his account has been hacked by someone and they have played the game PUBG. And one more game, Firewall. There was also one more incident. The Firewall, one of his friend or someone else hacked his username and password, and they have played instead of him, and he could not play it again. And he has asked many people his username and password. He couldn't retrieve it, and finally he ended up his life. So now you see the importance of this hackers and secure network. This hacking and attackers can attack any kind of things, and it can happen in power system also. It basically involves identify infrastructure, assess, evaluate vulnerabilities, threats, risks, implement security control, verify implementation of security control, ensure compliance to audit. And especially the purpose of this workshop for you people is to understand the power system. People will know the importance of electrical engineering. Normally, people will say that electrical and electronics engineering is a tough course, but it is one of the important courses. If you are interested in computer science engineering and information technology or ICT, information and communication technology, and if you are in electrical and electronics engineering, you can contribute to the electrical power system by this area. Okay. So what you can do, you can show your interest in securing the power system. Know very well that computer science engineering is a child of electrical engineering, right? So without electrical engineering, computer science won't exist. Without electrical engineering, electronics and communication engineering won't exist. Okay, we will be using these two things, electronics and communication and information and communication technology, that is ICT, to enhance the features of electrical and electronics engineering. So this is a simple network like internet, and all your computer systems are connected together, and finally the wire will go to the grid operation. And this is within a particular place, and outside the place we can connect it to a network by means of this is LAN and this is WAN. Okay, and similarly in the case of a power system we have generation, transmission and distribution. So even if you see here, all these things are connected together in a wired format. And in an industry, we have many devices to be operated. This is a physical process. And inside that physical process, you have many, let me take the pointer. And inside that, we have many component many machineries. And all these machineries are being connected. And these machineries can be controlled by means of a particular operating system. Okay. So this is one of the example of a power generating station. You can see there are a lot of communication networks available. Any doubts so far? Any doubts?
Network upgrade media. Coming Monday.
Yes, sir.
20 ka.
Chandramohan, sir.
Any doubts? Okay. So what is IT security? What is information technology security? So mainly to ensure confidentiality, integrity, availability. This we call it as CIA. In cyber security, the CIA is very, very important. Confidentiality, integrity, and availability. And this has to be done, this has to be maintained during processing, storage, and transmission. And this can be done by applying a proper policy and procedures. We need to form a proper technology, and we need to give awareness to the people about the importance of cybersecurity and importance of protecting the data from the hackers by means of education, training, and giving an awareness. So this is all about IT security. And actually, more than this CIA, we need to identify the requirements, identifications, and specification. And we after that we need to design and analysis develop and verify, operation and maintenance, and finally we need to dispose it. Okay, it takes the whole life cycle process of technical system of an organizations. And what part does cyber security relate to? The cyber security, we have different layers. It can be a component layer, communication layer, information layer, function layer, business layer. So in all, don't worry about these things, just for an information. In all these layers, it is possible to attack. Okay, we need to protect our systems from all this, in all these layers. So these are the different types of threats. We can have fraudsters. I think many of you have get a call asking about your ATM number, your Aadhaar number, PAN number, etc. Those people we call it as a fraudsters. Okay, and we can have different criminal. These people we can call it as a hacktivist. Okay, hacktivists. And unknowingly, what we can do is we may download an app or we can download a software, and that software will consist of a ransomware. The ransomware may say that you can get money by clicking on this particular button. Okay, if you pay, we can get money by playing a particular game. This we call it as a ransomware, stealing money, and botnets and their operators. Okay, and malware. And these people we call it as a professional hackers, or simply hackers. And we may get a technical failures in the machine because of the trial and error, because of the wear and tear, and because of the users, we ourselves make or commit some mistakes, and we may get some errors. Okay. So in information technology, vulnerabilities are all around, and these vulnerabilities due to complexity, multiple layer, and interdependencies. For example, from physical signals, let us say I have a machine. This is my computer. Let us say this is my PC. This is my PC. Assuming that I have a laboratory. Okay, this is my lab. You have an electrical machines lab, right? Let us say I have an electrical machines lab, EM lab. EM lab. So I have tables, table 1, table 2, table 3, table 4, table 5. And each and every table have motors, M1 to M5, let us say. Let us say. And all these motors are controlled by means of this PC. Let us assume. So, whenever you go to your laboratory, how do you connect your equipment? We will be getting components from the store. This is a store. And you will carry these components and you will place it on a table and you will be connecting this motor. This is your process, right? This is your process. So let us say, if I am able to control all these machines operations with the help of a PC, then what should I do? I need a communication protocol between the PC and the machine. And I need a dedicated software here in this PC. So here, the probable vulnerabilities which can be hacked are like this. There may be a failure in the machine. There may be a failure in the communication. There may be a software problem inside the PC. Okay? There may be a wrong machine connected to this motor. Because of the wrong communication from the store, wrong machine connected to a motor, and because of that, there may be some errors. So these are all the vulnerabilities are all around. Okay, hope people will understand. Why industrial control systems are vulnerable? I have given an example of lab, but the same thing happens in an industry. That we call it as an industrial control systems. Why these industrial control systems are vulnerable? Systems are traditionally designed and tested for an ideal condition, but in the house or in an industry, it is not an ideal condition. It may be, or it should be operated at different conditions, different operating conditions. Because of that, we may get some error. Why ICS are vulnerable? Because of the technology, because of the connections, because of the data flow. This we have discussed. And there are different level of vulnerabilities. For example, the SCADA, we have a software. And the software, we can have different operating system. It can be an Unix operating system or a Windows operating system or any other operating system. And all these can be connected to PLC, remote terminal unit, intelligent device, switches, routers, etc. These are all the design, these are all the components. And these components are connected together in a particular network. And these network are being operated by a people. It can be an individual people or an entire organization and based on some operations. So problem can happen at any point of time. This particular PC may fail. There may be a failure in the network. The people may operate it wrongly. So these are the different level of vulnerabilities. And common vulnerabilities in ICS are documentation, access control, network design, and security countermeasures. Okay. So there are certain software and there are certain network or there are certain websites available for identifying the potential victim devices. You just go to this particular website. It is like a Google, and it is for the public access. It is a computer search engine, partially free of charge. If you want to have the full version, you may need to pay. But for the students, it is just to check whether these devices are possible for hacking, etc. We can check it with that. And helps people to find webcam, fridges, RTUs, etc. according to country, ports, services, organizations, operating system, install software packages, etc. So this is some of the engines which can able to help the people to identify the hacking system. Fine. So far what we have discussed is like what do you mean by grid and what do you mean by smart grid? This is the first point we have discussed. And by understanding the difference between a grid and a smart grid, we came to know about the importance of cyber security in a smart grid environment. And in smart grid environment, we understood there are 7 different domains available, and all these 7 different domains are connected together. And once it is energy internet, and once internet comes into the picture, then there are possible methods for hacking or attacking. And we have also discussed about different types of attacks and different types of vulnerabilities. Okay, and different types of attacks we have checked it in smart grid environment. Similarly, we have checked the attacks that happens in an industrial control system. So this is the importance of cyber security in a power system. So based on finding out the importance of cyber security, there are many initiatives taken in India. And first initiative is IT Act 2000. In the year 2000, India have framed a security act called as Information Technology Act. This was amended in 2008. It is the primary law in India dealing with cyber crime and electronic commerce, e-commerce. You need to understand this act because if you have a mobile, if you have ATM, you need to know what is IT Act 2000. It is not manually possible to memorize everything, but if you have any problem in mobile phone, if you have any problem in ATM, if you have any problems related to cyber security, then you need to understand this act. It is already amended in India. Okay? And next, we have National Critical Information Infrastructure Protection Center. It is formed by Government of India under 70A article of IT Act. Okay. And 2 important documents are guidelines for protection of critical infrastructure, framework for evaluation of cybersecurity. In this act, they would have mentioned what is the solution for a particular cyber attack. Okay. And next one is Computer Emergency Response Teams, CIRT. It is also under IT Act as per the article under the section of 70B. Okay. As per Rule 12(1)A of IT Rules 2013, it is mandatory to report specific cyber security incidents to CERT team. So if you face any problem in cyber security, you need to inform CERT. Then CERT will take action. Similarly, we have ISGF documentation. ISGF is Indian Smart Grid Forum documentation. They have prepared a framework for laying down procedures for securing India's smart grid from cyber attacks. You need to, I have not included many acts, but I have included the important acts which is related to cyber securities in India. Similarly, we have ISO 27001. ISO 50000 is for energy management system. Similarly, ISO 27001 is for Government of India under the Technology Act 2000 and rules therein for reasonable security practices published in 2011 require all organizations to implement ISO 27001 as the recommended information security management system for legal compliance. Your college might have ISO 9001. ISO 9001 refers to your college is producing quality engineers. It is a mandate. Similarly, ISO 27001 is to check our college is secured and it won't get attacked by means of cyber hackers. So I need to follow ISO 27001. Any doubts so far? Any doubts? Organizers, any questions in the chat box?
No, sir.
Okay. Other people are listening?
Yes, sir.
Yeah, fine. Okay. Fine. Similarly, those cyber security laws are in general. Similarly, we have cyber security in power sector specifically. That we call it as IEGC, Indian Electricity Grid Code Class 4.6.5. People need to memorize these laws, okay? And this class specifically talks about how to secure a grid from hackers. Similarly, Indian Standard 1633.5. It will tell you about power control system and security requirement. And similarly, Central Electricity Regulatory Commission, CERC, they have given a regulation, Communication System for Interstate Transition of Electricity Regulation 2016. So these are all the initiatives taken by Government of India for the topic related to cyber security. And this is the reason cyber attacks happened. Each and every attack is so unique, and I think electrical engineering people might have noticed it, but this is of a world importance because every attack has created a huge loss to the particular country as well as to the world. Cyber attack in the form of ransomware virus hitting more than 150 countries, blackout in 3 cities of USA, cyber attack on Ukraine's power grid, cyber attack on hydropower generation in New York, cyber attack on Korea Hydro Nuclear Co. Limited in December, and security breach in Iran's nuclear plant. You see how they have communicated, how people have attacked. Earlier, we used to fight with the neighboring countries with the help of guns and bombs. Now we can fight with the neighboring country with the help of simple software. Okay, if I want to attack a particular country, if you cut the communication, that's it. If I want to attack a particular country, if you cut the power, that's it. Nothing will happen in that particular country, right? So this is the importance of cyber attack. Similarly, there are so many attacks available and so many history available. Please go through it. Similarly, in Indian power sector, in the year November 2017, hydro utility in northern India region has been attacked. Similarly, in the year 2018, Discom website ransom call in Bitcoin has happened. Now, cryptocurrency is of a great importance, right? People should know about blockchain. People should know about machine learning. People should know about deep learning. Okay, to understand the concept of these cyber attacks. So this is an important statistics, and it was taken by Department of Energy, US, and as per statistics, majority of the cyber attack has happened in energy sector. 53% of attacks in cyber has happened in energy sector. You please understand the importance of cyber security in power system. Okay. So these are all the areas vulnerable to cyber attacks in the power system. We can attack the hardware layer. I told you the earlier I have given 7 different layers that is related only for the software for every system. Now I am going to talk on power systems and different layers in which people can attack. First one is hardware layer. Any PLCs, any remote terminal units can be hacked, and it can be switched on and switched off automatically from the remote place by any people. And firmware layer. The firmware resides between the hardware and the software. The firmware is the operating system. It can communicate the hardware and the software. And the software layer. For example, in the operating system, whenever you insert external device, whenever you insert an external device, it is possible for the people to attack. And the next one is the network layer. You have LAN, WAN, etc. So because of the intrusion of any person in the layer in the network, it can be attacked. And next is the process layer. The particular control system can be hacked. Particular control systems can be attacked, and the process can be interrupted. So this is called as the process layer. So what are the issues in cybersecurity? See, first of all, people doesn't know the importance of cybersecurity, and people doesn't know whether it is being hacked or not. I can tell you, many people can hack your power from your home. Pilferage, as I told you, pilferage. Similarly, any people can track your data. Many people can track whether you are in the home or whether you are inside the particular city, etc. Okay, when you are connected to the net, people can be easily hacked. Okay, what is the issue? We don't have a proper security standard for this. Only now people understood the importance of security, security, and they have friendly issues. And we need to create a platform for sharing the cybersecurity incidents. If and only if we know some of the examples, we will be aware of that particular threat. See, many people, as I told you, many people have received a call asking you people to tell the ATM number. If and only if you know about the importance of CVV number, you won't tell it to the public. Or otherwise, just like that, you may tell your CVV number in the ATM card to the random people, and all the money in your bank will be hacked. All the money will be taken by the particular people. You may say that I don't have any money in my account, but that account number and the ATM number may be misused. Okay, it may be misused by the terrorist. You don't know the importance, and sometimes some people, police may come and lock you up. Okay, so this is the importance of the data, and this is why you are not supposed to give your data in public. Okay? And we need to strengthen the cyber security systems in generation, transmission, and distribution sectors. And following 6 areas need to be addressed for cyber security. First one is vulnerability assessment. In order to categorize the devices in terms of high risk and general vulnerabilities, we need to identify the devices. Second one, assessment area. See, there are in a computer system or in a power generating system, there might be huge number of switchgear components, and these switchgear component can be controlled by supervisory control and data acquisition system network. It is in a network. So we need to identify which are all the critical systems, okay? And we need to prepare a framework for testing that particular equipment. We need to form an asset map, and these equipment has to be monitored continuously, and it has to be audited. Okay? So this is the organization structure of cyber security in a power system. Under Ministry of Power, under Ministry of Power, as I told you, right, we need to have a separate CISO and CERT. And CERT is there for different generating station. CERT nodal agency for incident response. If at all if any power theft happens or cyber security problem occurs, immediately my point of contact is CERT. And CERT will take action accordingly, depending upon the intensity of the problem. So now let us see about the cyber security fundamental. In the previous slide, I have told you the importance of CIA. CIA. You need to remember this terminology, CIA. If at all, if any cyber security comes, then you need to remember CIA. What is CIA? Confidentiality, integrity, and availability. So the purpose of cyber security is to continuously ensure the required level of CIA. How well you are confidential about your device, how it is being integrated, how available it is for the public, for the private, for yourself. Okay? Cyber security can be summed up as a continuous process of assessing the network, implementing the physical, technical, or policy control that balance CIA. So, whenever you say cyber security, either it can be for a computer network system, or a SCADA network, or for a power generating system, or a power system in simple, you need to understand CIA. So satisfying these three criteria is a constant balancing act because each and everything are interrelated. Confidentiality is related with integrity, integrity is related with availability, availability is integrated with confidentiality. So advanced meeting infrastructure system require high level of CAE. Okay. So cyber security core function, as I told you, NIST, National Institute for Standards and Technology, identify five core functions for cyber security. Identify, protect, detect, respond, and recover. So you need to understand two things. One is CIE, you maintain confidentiality, integrity, and availability. And apart from that, may identify five core functions. I identify, protect, detect, respond, and recover. What is identify? Develop the organizational understanding to manage cybersecurity risks to systems, assets, data, and capability. You need to identify the problem first, and after identifying it, protect it, and develop and implement appropriate activities to identify the occurrence of a cybersecurity event. You should make a proper system so that it may not happen in future. And you need to find a system for responding it. So after that, how to recover it back? So these are the five core functions we need to maintain for cybersecurity. To understand the core function, one must understand the risk assessment, adversaries, and controls. So I am repeating it again. First one is CIA. Second one is identify, protect, detect, respond, and recover. Okay, IPDRR. You remember it like that. IPDRR. After that, you need to assess the risk. Based on the risk assessment, you may prioritize the work. The steps in this process include risk, threat, vulnerability. For example, let us say these two breakers can be operated remotely. If it is operated remotely, I need a communication protocol and that must be connected to an internet. Then these are all prone to hackers. These are all easily hacked. These are all vulnerable breaker, meaning is it can be easily attacked. Okay. So I need to check what is the probability of attacking these breakers. Based on identifying the probability, I need to secure the system. Okay. Adversaries are the key component of identifying function to recognize one adversaries. Adversaries include external and insider threats, individuals and organizations, and those motivated by politics, finances, or personal reasons. So, insider threats can be disgruntled employee or disgruntled means disgruntled employees. And adversaries include nations, hackers, terrorists, etc. And after that, after the risk assessment and adversaries, you need to control it. And controlling can be done in many ways. That may be a physical control, technical control, or administrative level. Okay. Physical control include fencing, locking, keying, and badging system and security camera. Technical control includes passwords, biometric, firewalls, and encryption. And administrative control includes policies and plans and procedures. So each and every slide what I have given is an important slide. I'm not going in deep, but these are all very, very important. And each and every topic we can do projects by means of simulation and hardware. Okay. And controls are how one executes the core functions of protect, detect, respond, and recover. You have identified already. I is over. Now I need to PDRR. Okay. PDRR. So now let us see how do I do cyber security for electric power control and automation system. So if I say electric power control system, then it includes the process control and SCADA. And that has to be operated in a safe, reliable, and efficient environment. And inside the process control and inside the SCADA, there might be varieties of communication network. You take from RS-232 to RS-485, Wi-Fi, RFID, NFC. There are a lot of communication protocol available in SCADA and in process control. And this grid and this system has to be sensed, monitored, and controlled. Okay. And there might be a lot of computer and communication devices. So, all in this case of a power system, the communication and control we call it as a power system security, cyber security, or power system control. Okay. And cyber attack scenario is mainly to penetrate the substation and alter any of the operations. What they do normally, once you hack it, let us say I have a power system. Let us say this is a GTD, generation, transmission, or distribution. Let us say I have a hacker. The hacker will go inside and they do what? Just switch on or switch off. If it is in off state, they will take it as an on. If it is an on state, they will make it as an off. Or otherwise, they may steal the system and so that the generation can be given to somewhere. Instead of A, they give it to B. These are all the possibilities of attacking. So I need to understand what happens if A is controlled by B or if A is transferred to B. So that has to be understood before attacking, and we need to take a proper steps for attacking. And this cyber security system can be involved based on the stages of SCADA. So SCADA system involves 3 stages: monolithic, distributed, and network. Monolithic is the basic stage of SCADA. Okay, it is a standalone system with no connectivity to others. One machine connected to another machine. One PC connected to another PC. A simple system, no network, nothing. So this we call it as a monolithic. Example: communication of a remote terminal unit. Okay, and distributed architecture of a SCADA distributes the computing burden to a number of machines in the network. So let us say I can have different types of machines connected together, and all these machines can be connected in a simple operating system. Similarly, these things are also connected together. So this is a distributed network. Okay, and this PC and another PC can be connected together, and this PC may be in a remote place. This is called as a network. Hope people will understand. Mono means single, Distributed means like this. Network means computer to computer, machine to machine. So power system security vulnerabilities. So PSC threats arise from cyber attacker, targeted cyber attacker, flood-based cyber attacks. So now, as of now, we understood what is cyber security and what is cyber attack, what is electrical grid, what is smart grid, and what are the laws and act rules and regulations involved in cyber security. Now we need to know, we have once we said different types of attacks, but now exclusively for power system, we may have different types of attackers. First one is cyber attackers. Cyber attackers concentrate only on SCADA system, and they may have two sources, internal and external. Internal within the company, external outside the company. Simple. And within the company, if it is attacked through cyber or internet, then it can be called as internal disgruntled employees attackers. Or externally, we can attack by means of introducing a malware or introducing a ransomware in the machine. And targeted cyber attack is like by means of ISP. Okay, they will target a particular intelligent electronic device. They may target a particular RTUs. They may target a particular DTs. They may target a particular uplink. And if they have targeted one particular system, then it can be called as a targeted cyber attack types. And next one is flood-based. Flood-based is similar to avalanche effect. Like a group of messages will be sent, malicious messages will be sent, and if you open that message, then it will attack a particular system, particular operating system, particular computer system. Okay, this is called as a flood-based attack. And how do I do the security? So far we have discussed what are the possibilities of attacking in the power system. Okay. Now let us see how do I secure my system. Okay. So any doubts so far? Any doubts so far? Organizers, any doubts?
No, sir.
Any doubts in the chat box?
No, sir. No, sir. You can continue, sir.
So in the SCADA system, security can be based on some standards. We have to follow some standards and protocol. So with the convenience of internet and possible cyber threat exposure, the attack can be executed through TCP/IP protocol. The critical attacks in the SCADA system can be in the DMS, distribution management system, substation automation system, power plant process control system, and as well as in the control center. So in the power generating or in the electrical grid, if the electrical grid is being operated by a SCADA system, these are all the possible methods of attacking. The first three are considered at the substation or regional level, while the control center framework involves the system level. And all these things, wireless network may be used for local communication. And these access points may be used to exploit the network vulnerabilities. So once the system is connected to the net, there are many chances of giving the data. And once the data is given, there are many chances for attacking. So we follow CAP 1200 and other standards. Okay, NERC has constituted the compliance standard of CAP 1200 for power system to meet the network security requirement. And other SCADA standard also available like BS, IEC, ISA, AGA, etc. We follow IEC ISO 17799 standard. So in a particular SCADA system, if I'm purchasing an IED or if I'm purchasing an RTU, then that particular device should compliance with this particular standard. If in that equipment, if I have that standard mentioned, IEC 17799, it means that it is a secured device. It is secured from cyber problem, cyber security problem. Okay. And the salient features of the security solutions are one of the ultimate goal is to achieve an attack-proof network. An attack-proof network means firewalls and IDS, okay, and electronic perimeter. So these are all the proposed electronic perimeter that can filter cyber attack and stop unwanted traffic. So if I have an intelligent electronic device, I can put up a firewall, and that firewall can be in the form of a software. Okay, firewall can be in the form of a device. So before going into the device, my message will go through this. If it finds if it is from an attacker, it may not allow the data to go inside this IED. So these two are called as a firewall. Okay, electronic perimeter and firewalls. And we have a domain-specific IDS. So it will analyze the pattern and cluster, and based on the attack scenario, it can generate a signature. It can warn the user, stating that there might be a possible attack on this particular domain. And we can have a secure communication. We can have a VPN. I think many of you know about VPN, virtual private network, and IP security, IPSCC, to provide authentication, data integrity, and confidentiality. If I want to enter into a particular SCADA network, anyone cannot go inside. It will ask for a security network. So I have a virtual private network. I cannot just like that
Sir,
access.
sir,
Yeah.
sir, Murugesan sir has raised his hand. Murugesan sir, any doubt? Murugesan sir,
Ma'am, no, you hear me?
sir, your voice is not clear. Any doubt?
Madam, I will chat and I will put in chat. No.
Okay, sir. Okay, sir.
What happens, ma'am? Any questions?
Sir, he will be typing in chat box. You can continue, sir. Once the question has been typed into chat box, I will convey, sir.
Okay. So, and other best security practices are we need to follow NERC guideline. And we have an online vulnerability map tool. It is also useful to develop a vulnerability analysis tool to test whether the server, host, routers, and devices that are part of the SCADA network. Okay, if it is an unknown network, then it won't allow. This map tool won't allow. So this is almost like a security management technique. And these are some of the frameworks, our cybersecurity framework. So we know what is smart grid now, and what is CIA, and what are all the methods for hacking, and how do you secure from these hacking methods. And we need to form a framework. And framework is something like, what is the method to control the attack? To achieve the goal of the secure control center network and power infrastructure, a comprehensive strategy, a policy has to be developed. First one is threat and vulnerability assessment. We need to assess a particular network, what are all the possible threats and what are all the vulnerabilities for that particular threats. And based on that, we need to design a security framework. Okay? And third, integrate modeling of attacks and their impacts. And we need to train our model. And if at all, if any threats, attacks in future, the system won't allow the attack to go inside. And for the validation of defense mechanism. And finally, without money, we cannot do it. These are all these first 4 points are costless solutions, but it is a must. So we need to find out a cost benefit analysis, because sometimes people may think instead of spending money on this protection mechanism, we may be able to replace the system after the attack has happened. Okay, so we need to find a proper, cost-effective, efficient solution for protecting the system from the cybersecurity attack. And for the future, for the faculty who want to do research in this area, and for the students who want to do research in this area, we have a suitable modeling and evaluation technique. So everything can be modeled, evaluated, and it can be finally implemented. So some of the methodologies include attack trees, PNET model, integrated modeling of cyber and power security, SCADA test bed environment and validation. It is a particular environment where in which your system can be checked in this test bed environment. Okay, so for example, attack tree is a multi-level hierarchy structure based on some digital electronics. Okay. PNET is something like a tool, a software tool. It is the time to reach the main goal and the path taken by the attacker. Based on that, they have formed a tool for protecting the system from the attackers. And the security modeling and evaluation, it is also a simulation tool for protecting the power system. And again, the SCADA testbed and environment. So you will be developing a tool, and you will be having a dedicated software to check different IEDs and RTUs for cybersecurity protocol. Fine. So this is what all about cybersecurity in power system. So we have discussed about different types of attacks and different methods of attack and different solutions for protecting the system from the cyber attacks, etc. And we have also discussed about CIA, IP, IDPRR, and we have discussed about ACT, etc. What are the steps taken in India? We have constituted a committee under member. Okay, Ministry of Power constituted a committee under chairmanship of a member ENC to look into issues of power firms seeking into this cyber security attack. And these members of the committees are, we have many people. Okay. And action points on cyber security, they have reviewed the CEA regulations, testing and standards. They have created a test bed at CPRI Bangalore, and we have at different places of CPRI, Pune, etc. And they have given a guidelines, scheme for testing, and they have appointed a central electricity authority for coordinating the cyber security in the sector. They have formulated a council that is called as the Power Security Council of India. And people are given training and certification in this area of cyber security. Don't think that cyber security is not related to electrical engineering. Cyber security has a great role, and it has to be carried out in power system as well as in the control. And these are all the methods for securing the ICS environment. We need to identify and eliminate security holes, and we have this risk analysis, reviews. We have a particular tool, and we have a particular software for protecting this ICS environment. So we need to invest in both. We need to invest in the technology, and we need to invest in the software, as well as we need to invest in the people. Okay, so then only it is possible for us to secure the power system from the cyber attacks. So here I have given few. Sir, we can meet afterwards. I'm in class. So we have here I have. Sir, I'm in class. We can meet it afterwards. I'm in class. We can meet afterwards. So see the present status: appointment of organization and plant level chief information security officer (CISO). So this is the present status. 4 nodal officers are available. I have already given the organization structure for CERT thermal, CERT hydro, CERT transmission, CERT distribution. Okay. And way forward is request state chief secretaries to facilitate people. Okay. And second is identify organization-wise critical infrastructure. NTPC, NSPCP, Power Grid Corporation of India Limited, they have to identify and they have to implement. I think you people will remember ISO 27001. Always remember this. ISO 9001 is for quality. ISO 27001 is for cyber security control. And formulate CMP, crisis management plan. What happens if a particular generating station is hacked? How will I replace it? And security mock drill. You need to provide a mock drill, and we need to give awareness to the people what you people should do if at all if there is any cyber attack on a power system. And we need to have an information sharing and analysis center. Uh, and it is available in CEA website. You people go and see that. Okay. And we need to conduct training workshop on cybersecurity. The main motive of this CSIR sponsored workshop is to make you people aware the importance of cybersecurity in power systems. Okay. So I think you can copy this. These are the tools available. Excuse me. All are open source. You can very well check it. Okay. So cyber security, many battles and a war. If you know the enemy and know yourself, you know you need not to fear the result of 100 battles. If you know yourself but not the enemy, for every victory gained you will also suffer a defeat. If you know neither the enemy nor yourself, you will succumb in every battle. So this is the book, this is the wordings written in 5th century. And it can very well apply for the cybersecurity. Okay. So these are the new initiatives and need for the cybersecurity problem. National Power Portal, Geospatial Energy Map. You will understand the importance later and soon. National Power Portal and Geospatial Energy Map. And these are all some standards. ISO standard 27000, and a lot of series, and NIST standard, IEC standards available. And this still, these are all the standards available for cybersecurity problems. So smart grid, it is an opportunity, and we have to use this opportunity securely, safely, to provide proper generation, transmission, and distribution. And we have a small cyber security working group, and you need to join in this group to understand the importance of cyber security in power system. A lot of projects, internships available in this working group. And the guidelines for cyber security work group is available in this report, 7628. And in conclusion, cyber power system security is a critically important issue in present and for the future. And several research challenges has to be addressed. Like we need to give awareness to the people. We need to classify the type of cyber attacks. And for each and every classification, you need to provide the solution. And the future work includes like we can able to simulate we need to integrate modeling techniques, and we need to identify the cause and effect relationship between cyber physical systems, and metrics to quantitatively assess the vulnerability we need to identify, and all the simulation model has to be cross-checked with the real world problem. So with this, I would like to conclude. If you have any doubts related to that, cyber security and its control, you can very well ask me now. And before I conclude, I would like to show some of my books related, not related to this area. Some of the books are related to this area. Is I'll quickly run through it. So these are all the book related to renewable energy systems. And this work might be useful for the students, different simulation tools in electrical systems. And this book is related to power systems. This is related to power electronic converter for electric vehicle. That's it. So if you have